Hi everyone, this is Mr. Youngren again, and we're going to continue our work with quadratics, and we're still going to factor today, but now we're going to factor in a different form. So when the quadratic is in standard form, how can we go about graphing that? As always, there is a warm-up or an opening problem. You're going to graph both of these quadratics. They are in vertex form, so there's not much work you need to do. Just use some of the same rules that we've learned actually back in first semester, and also what we learned in our last lesson. So go ahead and hit pause, graph those two functions for your warm-up, and I'll have the results for you here in just a moment. Right, here are the graphs that you should have. The easy parts are identifying the vertex. Make sure that for your x-coordinate, you're switching the sign from what you see in the equation. And then the y-coordinate is always what comes after the parentheses or after the squaring. Then our a value, all I had you do here is identify it, but that doesn't mean you're only using it the one time. You should still remember our patterns of how we use the a value. So our a value in this first one is 1. So I'm first going to go from that vertex and go up 1 and over 1 in both directions, and then up 3 or 3 times that a value, and then over 1, and then from there up 5. So our pattern for using the a value is 1 times the a value, 3 times the a value, then 5 times the a value. So make sure we're doing that if we can fit all those points. In the second one, when you go and use your a value and go down 2 and over 1 in both directions, then multiplying that by 3 tells us to go down 6 from those next set of points, and we're not going to be able to go any further. So we actually don't need to multiply this by 5. And then we get these nice graphs. So like I said, we're going to actually be graphing quadratics, but this time in standard form. And so our goal is going to be to get it into something like vertex form, or something where we can have that vertex and the a value and follow those same set of rules. So this first part is asking us, explain your steps for how to graph a quadratics back in vertex form. And so our steps for doing that is, number 1 is plot the vertex, which when it's in vertex form, it's really easy for us to find, right? Whatever's inside the parentheses is our x, whatever comes after that is our y. The second thing we do is use the a value. And just a little more specific with that, I like to say that really what we're doing is we have a rise and a run, where the run is always 1, but we're rising by whatever that a amount is. And then the next steps are 3 times the a value is that new rise over run. And that's from that last point, so 3a and over 1. And then the last thing we do, if we have the room to do it, we're going to go 5 times our a value. And that's the new rise over run, which is 5a, and then over 1. So that's exactly what we learned last time, exactly what we just did in the warm-up. And this is essentially what we're going to want to do if we're graphing something in standard form. But the problem is we may not see the vertex right away. And so in addition to all these steps, we're going to have to find the vertex, not just plot it. So what if we were given a quadratic equation that's in standard form, which is y equals ax squared plus bx plus c? What information would we need to find in order to graph the quadratic like we did in the warm-up? We need the vertex. And we also need the a value. Now the a value is going to be easy to find. It's still just that number that comes right after our equal sign. It's the vertex that we're going to have to focus on finding here. And there is a formula for finding the x-coordinate of the vertex in standard form, and that is x equals negative b over 2 times a. Remember, b and a are just coefficients, or just numbers. And so we can take the value of b and the negative, so that just means the opposite sign of what b is in our equation, and divide it by 2 times a. And that's going to give us our x-coordinate. And then if we have an x-coordinate to find y, all we need to do is plug x back into the equation. So that's really what we're going to do, and that in addition to the steps that we explained above. So summarizing all this, our first step to find the vertex is to find the x-coordinate of the vertex by using x equals negative b over 2 times a. Step 2, take the x value and plug it back into the equation to find the corresponding y value. Once we have the vertex, we'll use our a value from there. All right, so let's go ahead and put this to work. And the first thing that before we actually graph, I'm going to ask you just to simply find the vertex of the 3. And we're going to do this for 2 of these. We'll save the third one for you to do in class. So I'm going to start off, and I write this down every single time I need to use it. This is how I'm able to commit this to memory, is to just continue to write it down. And that's negative b over 2a. Now, our a value is 1. That's the number in front of the x squared. B is negative 6, and c is 1. So when we're using negative b, that's saying take our original b value and switch the sign. So it was negative 6 in the equation, so negative b is a positive 6. And we're going to divide that by 2 times a, where a is just 1. So really we're doing 6 divided by 2, which is 3. So our x coordinate of our vertex is 3. And now to find y, we need to take this x value and we need to sub it back into not one of the x's, but both of them. So that way we can get y to equal just a number. Anytime that we're subbing a value back into an equation, it is a good habit to throw it inside parentheses because I can see where the squaring is, and it also reminds me that I need to do negative 6 times that x value of 3. All right, now when I do this, I'm going to do 3 squared first, which is 9, and then negative 6 times 3, which is negative 18, and then add 1. Once we get down to addition and subtraction, the best way to go about doing this is work left to right. So 9 minus 18 is negative 9, and then plus 1, and negative 9 plus 1 is negative 8. And so then we have our vertex of 3, negative 8. All right, let's do this. Let's have you hit pause, and let's have you find the vertex of 2 and 3 on your own. I will have the answers or the solution for you after you unpause the video, but take a few minutes, hit pause, and find the vertex of 2 and 3 in the whole class practice. All right, so I have actually finished number 2. I got most of the way down with number 3, but I'm going to actually talk about a couple things with that. With number 2, one thing to be careful of is after you find the x value to be negative 4, when you plug this back in and you square negative 4, remember that squaring a number is going to always result in a positive value because anything times itself has to work out to be a positive. So negative 4 times negative 4 is a positive 16, Mr. Youngren, which is going to change what these y values work out to be. So be very careful of doing that. Okay, you can see even I make this mistake, so we want to always be thoughtful as what is negative 4 squared or anything squared, and that is going to be a positive 16. So this is actually going to work out to be negative 16 plus 15, which is negative 1. So the vertex here is actually negative 4, negative 1. All right, then for number 3, the vertex or the x coordinate, we're going to take negative b, which is positive 16, and divide it by 2 times 2, which gives us 4. Now, when we sub it back in, we need to think about order of operations. So the first thing I'm going to do is square the 4, because when we think about PEMDAS, that exponent comes before multiplication, because we do have a 2 times whatever the value we're going to get here. So 4 squared is 16, so I'm going to do 2 times 4 squared. And then I'm going to leave the multiplication here because we're going to do all our multiplication next. So I'm going to multiply 2 times 16 to get 32. I'm going to also do negative 16 times 4. If you need a calculator, definitely use it. And that's negative 64. And then add 29. And so now, just like I've said before, once we get down to just addition and subtraction, we should work left to right. In this case, since I have the calculator handy, I'm going to just type in that whole line, and it gives me negative 3. So our vertex here is at 4, negative 3. Now, there's a way that we can check this, right? We're essentially already doing it, but if I take the x value and plug it back in, I should always make sure that we're getting that corresponding y, right? So now, let's go ahead and put this to use. So can we do the x equals negative b over 2a, find our vertex, and now graph quadratics in standard form? So let's go ahead and work our way through these. So we're going to start off by finding the vertex the same way that we've been doing, of negative b over 2a. Notice how I'm writing that down every single time I have to use it. So negative b is a positive 2, and 2 times a is 2, so that's just 1. So I'm going to plug 1 back into our equation. And I get 1 minus 2 plus 4. I'm going to work left to right because I don't need my calculator. 1 minus 2 is negative 1. And then plus 4 gets me to 3. So our vertex is 1, 3. I'm going to plot that. And then our a value is the number that is always in front of the x squared, or right after the equal sign, which is just 1. So our first a value is 1, telling me that I need to go up 1 and over 1 in both directions. From there, I'm going to take the a value, multiply it by 3, now telling me to go up 3 and over 1 in both directions. And then if we have room, we would then multiply the a value by 5, giving me 5. But that's going to take me a little bit off the graph, so I'm not going to do that in this case. And we end with this nice parabola. So right, we're essentially graphing it in vertex form. We just need to do some work to be able to find that actual vertex. All right, let's have you hit pause, work through number 5. I'll have the graph waiting for you after you unpause. All right, here's your work for number 5. Finding the x coordinate, nothing weird. Make sure you're switching the sign for b, so it's a positive 4 divided by 2 times negative 1, which is negative 2. Then subbing negative 2 back in, make sure you're putting it in parentheses. Really helps to keep track of the order of operations and what needs to go where. Negative 2 squared is a positive 4. And so then once I have this positive 4, I still need to multiply it by that negative, or negative 1 that was out in front, resulting in a negative 4. I also did negative 4 times negative 2 to get a positive 8, and then we had a minus 8 there at the end. So once I got down to the very bottom, again, work left to right. Negative 4 plus 8 is positive 4. Minus 8 is negative 4. So our vertex at negative 2, negative 4, and then we're just following our a value pattern. So a, then 3a, then 5a. Tell me to go down 1, then down 3, then down 5, but the down 5 will not fit. So we are all done right there. All right, thanks for watching. Make sure you complete your video check-in and have a great rest of your day.